Good morning once again.
Dear participants, we are waiting for the sir to join. And after the sir will join, we will soon start the session.
Okay, sir.
Okay, sir.
Welcome again, dear participants. Sir has joined us, and after a wonderful morning session full of knowledge, we are eager to wait for another session full of knowledge. And without any further break, I'm handing our floor to the sir. Over to you, sir.
Can you able to see the slide?
Yes, sir.
Yes, sir.
Okay. Hope you are all maybe. What is your background, all of you? Because I was not asking in the morning. Do you able to understand? Because this is something related to environment and geology and all this.
Sir, I am from geography.
Good morning, sir. I'm from Botany.
Acha, acha, okay.
So I am from education department.
Education.
Myself in geography.
Geography. Okay. You will be able
I
to.
am
I'm
from political
from
Yes,
science.
sir.
Oh, okay.
So this is Dr. Lautik
I'm
from Zoology.
Geology. Okay.
I'm from botany,
Oh, okay.
mineral biology.
I am from
Uh,
sociology.
sociology. Acha. Good,
I'm
good.
I'm from Department of English.
Okay.
I'm from Education Department.
Mm-hmm.
Sir, I am
I
from
am from
Department
political
of
science, sir.
Zoology.
Political science. Okay.
Okay, sir.
I am
I
sir
am from
Department of Zoology.
history department. I am from history
Sir,
department.
I am from English department.
I am
Okay.
from
I'm from
Shrirampur
zoology,
College
sir.
department.
Okay.
Golpara College, Golpara.
मैं
Okay.
राजनीति विज्ञान से हूँ।
ओके राजीव विज्ञान से ओके सो ये सब तो आपको इंटरेस्टिंग लग रहा है कि नहीं लग रहा है क्या रिलेटेड है कि नहीं सब लोग रिलेटेड
हाँ,
नहीं है
related है
Yes,
sir.
sir. Yes, sir. Yes, sir.
New
Yes,
information
me
got
as
sir.
well.
Very interesting.
सबको
Yes,
पानी
sir.
तो चाहिए सबको
Sir.
तो पानी चाहिए ना वेदर यू आर पॉलिटिकल साइंटिस्ट सोशल साइंटिस्ट और कुछ भी है पानी तो चाहिए सबका हाँ?
Okay, sir.
Yes, sir.
एकदम ठीक बात सर.
So there is no discrepancy that no, even if you want to work in solving any environmental issues, we need to have this geopolitics. We need to have the social, cultural background of the people. So everything is related to everything in the nature. That's fine. Okay. Shall we proceed?
Right, sir.
Okay. Okay.
Yes.
Yes, sir. Please. Sir.
Nice.
Okay, sir.
Okay. So today, this is I will talk about the marine because India is having the largest coastal area, including Andaman, Nicobar, Lakshadweep, which is now Prime Minister went and become viral. So we used to work on the Lakshadweep and Andaman earlier on this when we are in the south and all those things. So you'll be finding the pristine Lakshadweep is, and also some of the islands in Andaman Nicobar is also very pristine. I was our hometown is very close to this region, so we used to just take a cycle and then go in the Saturday Sundays along with the friends and see the coastal areas and this. So the coastal areas. Because our Indian populations around 32% of the Indian population and the global population around 40% is living on the coastal area. So the coast is very important for our monsoon. Coast is important for our fish production. Coast is important for our aquatic system. Then the coast is important for barrier of the storms, some storm surges, cyclones, and all those things. So we have a lot of fauna and flora. You might have heard about Sundarbans. You can see the Indian Sundarbans and the Bangladesh Sundarbans. So relatively, Bangladesh Sundarbans is not that much disturbed compared to the other Indian Sundarbans. So you can see some of them like in Bombay and the near regions, Kutch regions and all, mangroves are relatively disturbed compared to that of the southern part of the mangroves in the eastern coast. Mahanadi, Bhitarkanika mangroves. Then we have the Pulicat lakes and then the Pichavaram mangroves, Koringa mangroves. So these are all we have, and it is also tourism also, and we have n number of minerals, starting from Kerala to the radioactive minerals, titanium minerals, up to Ratnagiri, up to the Orissa coast. You will find that lot of minerals in the coastal placer deposits in the regions. So population, culture, economy, fish production, and then the strategically, that is the coastal guards are there, which they are, and also there is a connection between the ridges there between the India and Ceylon. That is the natural ridge is there. we call it as the Ram Setu and all those things. So there is a natural bridges there. So coast is having a number of cultural and political and economical, social, environmental, all issues. And then you will find, and also whoever goes to the coast. So how do you identify you are nearing to the coast? Anybody has an idea? If you are going from the land to the coast, what is the indicator first that I am going close to the coast?
Humid climate.
Humid is there when the rainy season also there in Delhi also.
Uh,
Plant
yeah,
diversity, sir.
Huh?
Plant diversity in the coast area. Mostly
yeah.
we get
Yeah.
coconut
Coconut
and
tree, sir.
areca.
Coconut tree.
Yeah.
Areca,
That is,
marine transport.
fishes.
no, that is after seeing the coast only. You will feel it when you go near to the surface.
Salinity.
Salinity.
No,
Humidity.
The sound of the waves.
Huh?
The
Humidity.
sound of the waves.
Sound of that is only 1 kilometer. 10 kilometer onwards, you will feel that you are nearing the coast.
Humidity, sir. Environment change.
Vegetation.
Vegetation one, and then the salt
The
spray, sea spray, sticky
Yeah, that's what
aerosols,
salinity.
Sticky
Yeah.
humidity.
sodium chloride.
Yes, it's sticky.
Yeah.
Sodium chloride, that is the aerosol.
Neither cold nor
Yeah.
hot.
Either cold or that is so. And when you stand in the beach, why do you stand in the beach?
Sand.
Sand, to see the sand, or you feel
Or
it that is
waves.
Waves.
Or breeze.
waves. So waves, what they do?
High tide, low tide.
That is not
And,
wave, that is tide.
Tide.
Wave is that continuously due to the air water interactions,
Yes.
and it never stops. Tide will
Marine
come.
flora.
It is because of the
Marine
revolution
flora.
of the earth,
Pardon?
rotation of the earth.
That is tide.
Waves are
That is tidal. High tide, low tide, all those
Marine
things.
flora.
origin of waves are the rotation of the earth.
Yeah. And then Coriolis
It's
force,
because of
all those things will come into that one. You will feel that you will never disappoint. You have to approach. Wave will never stop, na. So you have to manage all your issues without getting dejected. That is what we feel. And also it will touch your leg and then go, and it will not sticky to you. It will not stick to your. Why
uh,
it is not sticking to your
there is
leg?
one time when there is sea breeze or land breeze. When you go in afternoon at Kanyakumari sea beach, you will face a very strong wind there.
Yeah, wind, land breeze, sea breeze. When the land is heated up, then
Yes.
it will
Mud.
attract sea breeze.
Mangrove plants.
Yeah. So the sand, why it is not sticking to you when you stand on there? When you stand on the river, sometimes it will sticks. Why it is not sticking when you are standing on the waves? Any idea?
It is
Due to
salty
climate.
water.
No, not only salty water. Sediment I am talking. Sediment is
Yeah.
not sticking to your soiling your cloth or anything, na? Yeah. That is due to the waves and sorting the grains. It will remove the clay and only it will give you the uniform sorting. That is why that in the beach you will not find and also you will find different colors of the beach: black beach, silver beach, golden beach. All these are named because of the grains mineralogy.
Grains, yeah.
Grains mineralogy.
The pebbles, the stones, the grains.
No, minerals. Anybody knows the minerals? It is having
Yes.
feldspar, quartz, alkaline feldspar,
Yeah.
potash feldspars, all those things in that one. So, and also we
It's
have a
because
lot
of
of
the
bio reserves, and we have marine bio reserves, and we have bay region where there is waves and or intensification less. There you can have the navigation and fishing. All those things are in the Bay regions. So let us just move on and see what I can share with you. So that is the age of the Earth is around 4.6 billion years. Solid surface is around 4 billion years, whereas our ancient ocean is around 1.5 billion years after the formation of the Earth. It happened. About 4.4 billion years ago, the oceans are formed. That is also oldest. The life started in the ocean only. That is cyanobacteria, the 3.58 billion years. The ocean is the first life started in the ocean. So the ocean is having a very important for life, for climate, for economy, everything is the marine and coastal areas are important. So the hydrosphere, the global ocean, the most prominent is the ocean covers 71% of the planet and represents 97% of the water. So only 3% we have in the glaciers maximum, followed by river, ponds and groundwater. The atmosphere, the swirling clouds of the atmosphere, which is also controlling the global oceanic movements in the regions, and also the Coriolis forces, all those things which divert the movement of the ocean water and atmospheric circulation patterns. So the marine environment, we define it as it's an open ocean, coastal seas, estuaries, intertidal zones, tidal and there is a classification is there, pelagic zone, tidal zone, intertidal zones, and characterized by distinct physical conditions such as temperature, salinity, currents, and tides. So we have wave, we have tide, we have currents, ocean current, ocean tides, sea waves. Coastal environments are dynamic zones where the land-sea interact, land-water interaction, land-sea interactions, characterized by beaches, cliffs. Cliffs you can see in Goa, when you go there, you will clearly see the cliffs and then suddenly ocean will come. Tidal flats, you might have seen if you walk around the Sundarbans, just far off from the Sundarbans or any Mahanadi coast or any coast, and then mangrove forest. I think most of you might have gone as a picnic or something like that. Whoever lives in the coastal area or goes to coastal area, especially not in the cities like Chennai and all, you will find very only 0.001% of mangroves. In Goa, you can see mangroves. In Bombay, you see only 0.01% where the disturbance, human interference are there, mangroves will not be there. Marine and coastal zones support the rich diversity of plant and animal life, and including because the plant, trees and vegetation, you rightly said, because of this typical vegetations that is that grows in the regions, that will reduce the wind speed. That is mangroves and the other species, they reduce the storm impact or storm surge impact on the land. For example, in tsunami, wherever there is a thick mangroves are there, tsunami impact is reduced to only 5%. Whereas the disturbed mangroves are, people destroyed the mangroves, like in Jagat Singh Pur in Orissa coast and all. The super cyclone has affected, tsunami has affected in the down south. They are having a lot of phytoplankton, zooplankton, fish, marine mammals, and all. Coastal habitats are included, also having the salt marshes, tidal flats, salt marshes, seagrass. This is also a staple food nowadays for most of the Asian people, South Asian peoples in these regions. And then it is also essential nursery areas. For example, mangroves and tidal floods are siblings of the fish, prawns, and crabs, which comes on the high tide, and then they take a shelter in these roots of these mangroves, and then they grow. Once they grow during the high tide, they go back to the open oceans or the sea coastal area, and the productivity of the sea coastal area increases. So there is a deep interdependency between the land and the coastal area. So ecosystem services, food productions, coastal protection, that is, I told you, tsunami, storm surge, climate regulations, nutrient cycling. This is very important. The river brings the nutrients and then they recirculated Some of them coagulated, some of them flocculated, and then they will be getting deposited. Something after deposition, they get released to the tidal physical and physicochemical activities and then released back into the system. So it stores and releases nutrients to the estuaries, mangroves, coastal areas, etc., etc. Coastal wetlands are क्या हो गया? What happened? Can you see or not?
Yes, sir.
Yes, sir.
So this is how these bacterial depth-wise also, if you go to the ocean, you will get a depth-wise also variation in the oxygen, variation in the temperature, variation in the carbon dioxide, variation in the bacteria, top to bottom, you will find the variation. So the productivity will be different in the top photic zone, aphotic zones, and all those things. So animals live even in the deeper part of the ocean. Even if you go to the average depth of the ocean, anybody knows the average depth of the ocean? Any geographer, geologist? Okay, you find out. So in different depth, different animals will be living, different physiochemical characters will be there. And some people believe that if you go to the deeper part, pollution is less. For example, Japanese people, they take only the deep water fishes which survives on the high pressure, where the lungs are having a high capability withhold the pressure. And then they dive deep into the ocean. Traditionally, women are trained. They go deep up to 1 kilometer deep and then take the fish. And then that's why they eat raw. That is sushi and all those things they eat because they feel that they traditionally believe that that is if you without cooking also they are not going to harm your health. They mix it with the like a ginger type. They have and then they mix it with that paste and then eat it. Nothing will happen, digestion and then healthy also. So there are different life systems and the different depth depend upon the light penetration, nutrient availability, pressure, etc. And 60% of the world population live near the coastal areas, 80% in coastal cities in the world, even including your California, San Francisco, the world famous Bombay, Calcutta, Chennai, any cities you talk about, famous cities, Singapore, Sydney, all those things, they are all in these marine regions. So our seas support endless natural resources, support wildlife, keep our climate stable and create employment opportunities. Coastal habitats protect us from extreme weather phenomena. And then unsustainable practices, this is what now disturbing our, you might have heard about the microplastics, which is the, and then the pollutions like not only heavy metals like your that is pesticides and then your cosmetic products, antibiotics, they are all end up in the ocean. That is along with the microplastics, whatever you use, your spray, body spray, they are all finally end up with there, and then you destroy the marine life, and then your plastics destroy them in that ocean. Emerging contaminants, that we call it as emerging contaminants. So this is the ocean provides oxygen, food, energy, water, and raw materials, jobs, and over exploitation, pollution, climate change happen. And 2020 agenda dedicates sustainable development goal 414, that life below water to conserve and sustainably use the ocean, seas, and marine resources. So our sustainability goal, most of the sustainability goals will be linked to water and the life and the poverty reduction. All those things will come applicable to the ocean and the marine and coastal environment also. It is only recognized the land-based human activities significantly impact the marine environment. 80% of the marine pollution originates from the land. Why? Man. We are the only culprits who did all these things. And land-ocean interactions, there are a lot of organizations emerging, international organization, UNESCO, UN bodies control. They want to regulate the things, but still a lot of things has to be done. So this is how the ocean looks like. If you go below the sea, below the water, if you see the ocean basins, we have the ocean basins. We get the Rift Valley, this African Rift Valley, famous Rift Valley, lot of lakes in Africa. If you go to Kenya and all, you will find these volcanic eruptions taking place and then form the lakes. They are having the saltwater lake, they have the freshwater lakes, flamingos. Millions of flamingos will be there on them. When you just clap your hands in these lakes, it will be like a carpet, a pink carpet. Suddenly it will emerge and then go. It will become green. So these are all due to this Rift Valley, submarine volcanoes, and then we have the abyssal plain, oceanic crust, and continental crust. The density difference is there. Highest density is the oceanic crust, and so the oceanic crust, in which that you will get a lot of earthquakes, volcano, and all those things. That is when they submerged. That is plate tectonic theory. Maybe you be knowing that one. That is convergent plates, divergent plate, and thrust fault. So they will be. So this interaction between the two density waters and then the tectonic activities they bring, and then they develop all these submarine, that is continental landmass, continental shelf, coastline, and then deep sea. So the deep sea also we have a lot of minerals starting from here to that here. Deep sea, Pacific Ocean. If you go to the deepest part, you will get the manganese nodules, the nickel, maximum nickel we get it from there only. And then the rare earth materials we get it from this coastal area. For example, in Kerala coast, Manawalakurchi in Tamil Nadu, all these regions, titanium and other uranium, thorium, phosphate in this region. So there are a lot of volcanoes happening in the land as well as in the ocean because of this region. And then we have the lot of classification. Mid-Atlantic ridge here will be there, and that each one is having the ridges and trenches in this region, which is the trenches will come here. So all over you will get a lot of trenches. Pacific Ocean will get a lot of thrust faults in this region. That is the ring of fire because of this interaction. That is the ocean submergence of this oceanic crust and the continental crust. You will get a lot of volcano earthquake. So the people of from that Hawaii, USA, and up to the Philippines, you will be getting this Pacific Ocean, the ring of fire in these regions because of this oceanic plate, continental plate interactions in these regions. So when you walk from the coast, land to the coast, and then the sea, and then the continental margin, deep oceanic margin, volcanic island, deep sea fans. This is what the delta. Bengal fan, for example, famous Bengal fan. If you go from the from the Hooghly, you go down deep. After some 2 kilometers, you will find the deep sea fans. So this fans brings a lot of nutrients and then recirculate them in that one. And then they also bring the that is microfossils, foraminifera and all that they later form into the hydrocarbon and the petrol in the regions, in this region. So oceans, you'll find the ridges, typically different geomorphological structures in the regions. And then every part of that is having an importance. Continental slope. The angle varies from 0.1 degree to 2 degrees in this continental slope. And then there will be a rise in that due to volcanic activity. So the continental rise, abyssal plain, all those things, typically you will find in different oceans. So that's why we classify the coast active and passive coast. Active coast, which may having continental crust and oceanic crust interactions more, where they leads to volcano, earthquake, and all those things in this region. For example, our tsunami is triggered by this deep ocean earthquakes, where the three plates of the Nicobar Island, Indian plate, they meet together, and then they triggered the earthquake, which it tends push up the water straight into the top, and then they form the tsunami, which rises about 30 to 40 meters in the coastal areas in the regions. So all are linked to the land-ocean interactions in the region. So this is how it looks like, and the vertical class sections: continental shelf, continental slope, continental rise, abyssal plain, oceanic trenches, submarine ridges, all those things. So if you see these things, 3D, that is what I told you, the plate tectonics. That is the convergent plates, divergent plate. This is the convergent plate, and then the divergent plates, and the thrust fault plate. These things. So transform fault. So that's the three plates. St. Andrews fault is the famous for that in the USA. This is how this looks like, and then we have the lithosphere, asthenosphere. The top part of the asthenosphere will started to moving because of the internal radioactivity and heat, existing heat in that one. Then plates started to move because it's like a lubricant in these regions. This lubricant pushes this this is a lithospheric plate, and then moves them, and then they collide with each other, which sometimes creates the our Himalaya also rising because of this collision of the continental plate collision in these regions. So if there is a two different density plates colliding with each other, that will lead to volcano. Otherwise, it leads to mountain building activities like in Himalayas. Himalayas still rising every year because of these collisions in the region. So we can also classify based on that pelagic in the open ocean, neritic near to the coast where the fishing activity is more than the oceanic part. This relatively a desert type of thing. You will not get not much productivity in this region compared to this region. Why the productivity is high? Because land is bringing a lot of nutrients, and then due to density differences, there is a upwelling, downwelling, and then the oceanic currents comes and meets. They contribute in Western Ghats, for example, Western coast, and then they bring the nutrients from the Arctic and Antarctic into the Western coast, and then they productively increase. So this is, we can classify further as a littoral, sublittoral regions, bathyl, abyssal, and benthic organism. That is below the sea, living as the benthic organisms lives there. Then epipelagic, mesopelagic, bathyl pelagic, abyssal pelagic, hadal pelagic. There are no life, at least no life. Darker light is not penetrating, no life will be there in that one. The temperature also, you can see that one, 10 degrees there, and then 4 degree, it will be on 0 degree. In that pressure will also increase in the region. So how it is important, this changes. So that is, we need animals to develop their shells to from the harsh wind as from the predators. They need calcium carbonate, then silicate, SiO2, all those things they need, which is also that we have the siliceous oozes, calcareous oozes, and calcium compensation depth, and aragonite compensation depth. All those things are very important in the ocean, which is helpful for the biological pump, that is the carbon pump, which when the top part of the ocean is having a lot of competition because of light is there, oxygen is there, lot of phytoplanktons will grow, and the fish will eat and survive, and then the other organisms also survive. So there's a lot of competition. There is a limiting nutrients are there in the surface of the ocean. So this will be compensated by these things when there is a tidal current comes and there is oceanic current comes. They bring up the bottom one to the top. That is why from the oozes it goes there, upwelling, downwelling, and the siliceous oozes. Like they will be having different animals will survive like radiolarians, which is mainly made up of the silica, which is also helpful for the productivity of the ocean. So we have calcareous oozes, siliceous oozes. So all these things below the hard rock, they will be having the soft sediments, the deeper part. They are the highly productive regions which circulate the nutrients, circulate the water, circulate the temperature in the regions. So this is what how this continental drift has been taken place from the 240 million years to the 60 million years, and then today we are like that. So puzzle has been a little bit solved and then modified by the plate tectonic theory in the regions. So water currents. So you feel that that ocean is very only surface we are seeing, but it is having a gyre, it is having the currents, which is transporting the heat from the one place to the another. So if it don't transport the heat and nutrients from one place to the another, so one area become more cold, one area become very hot. So for example, the California coast, and then they bring it from the Gulf Stream. The Gulf Stream brings the warm water and nutrient to the California coast, and then the harsh winter will be reduced to the spring and all those things in the regions. So the Gulf Streams will bring this nutrients from these regions and then bring it to the area. So they bring from the polar regions into the continental area, into the equatorial area and temperate region. From there it goes to the hot water will go there. So there will be a local circulation, gyres will be there. Then there will be a continuous circulation, currents will be there. So this is also helpful for the monsoon. Monsoon also will be getting because of this gyre movement in the regions. So all those things will happen if there is a change in the temperature from one part of the ocean to the another. If it is uniform temperature, then there is no density difference, then there is no pressure difference, hence there is no movement of the water in the region. This will happen if the climate change is happening, all the sea surface temperature will become uniform, then the whole system will be standstill in future. Maybe it will take 200 years, 500 years, I don't know how much it will. If you keep on adding this CO2 and raise the temperature. So you can see that how this red one shows the warm water, blue one shows the cold water. From the polar region, it brings the cold water and then takes this into the warm water in this region, then take back to that warm water. This is how the system works. Not only warm water it takes the cold water is having high density and high because there is no competition here. Lot of nutrients from the land comes and the nutrients will take it and then come here. They use the nutrients and the warm water will be transported here, the density difference. Then they keep on running this thing. Then you'll get the different currents, cold water currents, hot water currents, all those things which keep the system running and productivity increasing in the regions. So similarly to the air, the current is also, ocean current is also important. That is also affected by the Coriolis force and the Ekman effect, all those things which is affecting the wind also affect the water movement in the region. So this is the conveyor belt system, which is if it stops, the whole productivity in the ocean will stops, it will become standstill. So it brings the cold water, blue one is the cold waters, and then they become warm water. The cold water will come here and then they combine to the warm water, heated up, and then you take it back to the system. Again, it heated them and then bring the cold water. So nutrients and warm temperature water will be coming from the polar North Pole and the Antarctica, Arctic region, Antarctic region. So they will be circulating and keep the system. And then salinity also will be varying depend upon the transport of the atom. That's why this when it brings this cold water here, this area will become productivity. West coast is highly productive compared to that of the east coast. So not only the local currents, gyres, this also the conveyor belt system also conveys the deep in the deep ocean waters brings them. So we have the marine sediments, lithogenous, biogenous, hydrogenous, and cosmogenous. Lithogenous are from the land, they bring the weathered materials, nutrients, and then that is why we get the terruginous and red clays. The clay is a very important component. The first life started in the clay, which is having the cation anion exchangeability, fine size, larger surface area, and it's also having fluvic acid and other things which helps them to the productivity. Then biogenous sediments, that is what I told you about that the fishes and other things, they need the calcareous uses, siliceous uses, and their shells are made up of calcium carbonate, siliceous component. Then hydrogenous compound, we get a lot of hydrogenous compound, that is the precipitation of the minerals. The manganese nodules, for example, is the hydrogenous sediments. Biogenous sediments help them for the formation of hydrocarbons, petrol, and all those things. Cosmogenous sediments are probably most important, which is coming from the Earth, from meteoroids and asteroids. So that is also affecting them. So we have the clastic, biogenic, and chemicals. We can also classify them further. In that one, you get the. If you go to the salt pan, anybody might have seen the salt pan. Anybody have seen salt pan?
Which we use in our home. Salt pan?
Salt pan. You have seen
Yeah.
productivity of salt.
Oh.
No, sir. Not
No.
really.
It's
See,
of
if you go to the
geological
coastal area,
subject.
there will be a lot of agriculture, like agricultural land. You will get the salt pan, different salt pan. They will pump the
Oh,
saline.
deposition of salt in the agricultural field, I think, sir.
Huh?
Deposition of salt in the agricultural field in coastal areas.
No, not agricultural. It is tsunami time. It is deposited on agricultural land. Otherwise, there is a specific land. Dandi March, Gandhi, Dandi in the Gujarat. No? That is a land which is always a salt marsh area.
Produce salt.
Yeah. So that area we will pump the water and evaporate it. There we will get the top layer, evaporate it, keep it for 10 days.
Okay.
And then they are also farmers. We call them as a farmers. They evaporate it, and the top one will become sodium chloride. Bottom will come calcium sulfate. That is gypsum, which is used for fertilizer. Which is used for fertilizer. So that is one type of salt we are using it. There is another salt is called rock salt. I think in North India people use the rock salt, na?
Yeah.
Where from it is coming?
सेंधा नमक. हाँ.
काला नमक कहाँ से आ रहा है?
काला नमक is from I think Himalayan region.
अच्छा, ठीक है. Anybody is from the coastal area, Gujarat or anything?
No, we are in
Ran of
plain
Kutch.
areas.
Have you heard of Ran of Kutch?
No.
Yes, sir. Yes. Gujarat.
There the paleo oceans have been evaporated and formed the rock salt. So that is the rock salt. That is what we get it from that. So it is all the natural. That is why that kala namak rock salt is more nutritious than this salt pan sodium chloride. That is why
Where
people
it
say
is
that is very strong because
produced, the Kala Namak, where it is produced, sir, in Ran of Kutch.
it is produced by nature. It is produced by nature, paleo ocean.
Okay.
Paleo
But
ocean
anywhere
occupy the
in
land.
coastal plain.
Yeah, it happens in only in Gujarat. We get a lot of rock salt border, India-Pakistan border.
Okay, that's why. Good. Okay, sir.
We should know what we are eating now, where it is coming from.
Yeah.
So this is how the deep ocean mining, manganese nodules, barite, and all these minerals, hydrocarbon, how they do it. Deep minings and then excavate them and take it back. Nowadays, people are mining the sand also because we have exhausted all the river sand. Now we are going to marine sand to build our house, to make the impermeable layer, very important impermeable layer where the water cannot percolate into the land, and then reduce the groundwater to minimum. So all these are nowadays we are taking it from the ocean. Now we are overexploited river. We are going to overexploit the ocean.
Oh, yes. So true.
This is how the manganese nodule precipitated in the deeper parts of the Pacific Ocean. It is having the manganese, nickel, copper, all these metals. India having a lot of mission also done from the Ministry of earlier Ocean Department. Now it is called Ministry of Earth Science. That is doing this, and then we are having an expedition going there to Arctic, Antarctic, Pacific Oceans, etc., to understand and enhance our economic benefit and also this.
Minerals.
This is how these different types of sediments occur in different parts of the globe. Heterogeneous, You see, the rivers bring and then they become terrigenous. Carbonate sediments, there will be and the carbonate oozes, siliceous oozes. In the cold area, you will get mostly siliceous oozes. Clay materials you will get. So this is how the ocean is having a lot of surface sediments, which is actually storing the nutrients and release back whenever it is needed for the water column and the phytoplankton productivity, and then the fish, crab, all those things will be survived because of the nutrients. There is an interaction between the sediment and water due to the current, tides, and ocean waves. So this is how the thickness in meters varies from that one. Every part of the country will be having a different thickness. You see that one? See, East Coast will be having the thickest one because we are getting a lot of input from the Ganges, Brahmaputra, Padma, all these Ganges, Brahma, Padma river brings, and that's why you get the 1000 to 2000 meter thick sediments, Bengal fan and all form. So the thickness varies in the region. The lowest thickness will come in the west coast because productivity is high. The rivers bring less water. Narmada Tapti is the main one which brings the sediments. Remaining are all small rivers in this region, and it is deep. And then the oceanic conveyor belt system brings nutrients. That's why this part is productivity, highly productivity. So lithospheric age also varies from 0 to why that is the lithosphere plates are relatively younger age than the oceanic plates because the lithosphere the plates will be consumed. These plates always consumed and then really and then emerge. So there's a age is very less for them. And then we can classify the further pelagic zone, benthic zone. I told you the neritic, pelagic, benthic, pelagic, and benthic zones. And that depends upon the ancient word pelagios. Benthic is the ecological region, lowest level of body of water, such as ocean or lake, bottom one. And then photic zone, dysphotic zone, aphotic zone. Photic zone is maximum protected because light penetrates. Photosynthesis happens. Phytoplankton produce. Then dysphotic zone relatively less than 200 meters is that relatively less photosynthesis, less productivity, and it will aphotic zones less productivity compared to the this photic zone. So that is why we classify as epipelagic, mesopelagic, bathypelagic. The different animals live in different parts of them, depend upon how much they survive the salt, how much they survive the pressure, how much they survive without oxygen. It all depends upon that they survive. So this is where the mangroves and the coral reefs. Just 30 degrees from the south, north of the equator, you will get coral reefs and mangroves. And some of them will get the deep, but maximum productivity occurs in these regions because of sunlight, because of oceanic currents brings the nutrients from the polar regions. So all these regions will be highly productive in this region. Fortunately, India is also coming in that one. That's why we are having high productivity in the region. So we know that the carbon dioxide is increasing. We need to have something to do that. In the past 50 years, 100 ppm has been added to the atmosphere from 1850, and then that is why there is a concept to emerge blue carbon. United Nations Environmental Program developed a blue carbon because the coast will act as a sink for the so the blue carbon. What is blue carbon? It refers to the carbon captured. There is a green carbon, there is a black carbon, there is a brown carbon. There are different carbons, we call it. One of them is the blue carbon. Blue carbon refers to the carbon which the world's coastal marine system. These ecosystems such as mangroves, salt marsh, seagrass, meadows plays a crucial role in mitigating climate change by absorbing and storing large amount of CO2. That is why we need to conserve the coastal area. It is not that only we are living in Himalaya, we don't bother about coast. We live in the coast, we don't bother about Himalaya. No. Everybody has to bother about everything. Mangrove, these dense forests and shrubs thrive because they also take from the salt water, fresh water, and the intricate root system trap sediments, organic matter, creating rich urban soils, and can store up to 4 times more carbon than the terrestrial rainforest. So terrestrial rainforests, it is far better than the terrestrial rainforest to store the carbon. And then salt marshes, that is found in temperate regions, and salt tolerant grasses and herbs will grow there, and they also store carbon. And seam grass meadows. These underwater meadows, if you go to the Gulf of Mannar, you can walk around that, and a little bit you go far off, you will find the seagrass floating below the seawater. They also captures, they are very important for the phytoplankton productivity, coastal productivity, and also people are using that for our consumption, day-to-day consumption also. Seagrass captures CO2 through photosynthesis and store it in their leaves and the underlying sediments. So for climate mitigation, we need to conserve these parts so that blue carbon will be there, erosion will be less, and strong nutrient soil will be there, fish production will be there. For this purpose, we have to restore all the conserve and restore all our coastal area. So selected sustainable blue carbon economy. What a blue carbon, if it is good, lot of storage is there, then fishing will be good, aquaculture will be good, tourism will be good, all will be good, marine renewals will be good, submarine cabling will be good. Because in the Ukraine war, you can see that one, the submarine fuel was broken, and the whole Europe is not getting the fuel, gas, and all those things. So coastal mining. So if you have a sustainable blue economy, this is all are related to ocean blue economy. Ocean, because the cheapest way of transporting materials compared to the air, and also polluting less in the region. That's why the blue economy is growing. So this is how the carbon cycling, we have phosphorus cycle, you might have read it in your +2 also, all those things. So the different components stores the different parts of different CO2, and then they release us back into the system. And so this is how the seagrass looks like. You can see that seagrass is like that. Saltwater regions, you will get it. You might have seen maybe in the undisturbed regions, you can see this one. And then this is how the mangroves, this is the breathing roots, which filters the salt water and then take the fresh water to them. And the salt will be deposited on the backside of this leaves. So it will survive in the high salinity water. So India, the globally also, you can see all of the green one is in the 30 degrees north and 30 degrees south. In India, you have the Gulf of Kutch to that of the Sundarbans. So many mangroves we have. But pristine is some of them in pristine Sundarbans, Bhitarkanika, some of them pristine Kuringa, Krishna, Pichavaram, Muthupet. This is a lagoonal one. Vembanad is restoring that one. Lakshadweep is very good mangrove stored there. Only one island. Remaining are all disturbed there. In Andaman also, 1 or 2 islands are disturbed. Gulf of Kutch is almost disturbed. They are rejuvenating. Gulf of Kambat is there. So these root systems, which will help them, any storm or tsunami comes, they will withstand. They are flexible. They are flexible. They reduce the wind speed is coming. For example, super cyclone is 360 km per hour. It will reduce them to 100 kilometers per hour. Then the impact will be less. For tsunami, also they reduce it. And then supply nutrients. All the siblings comes and store, and then when they are very small, they come here, siblings will come and stay here and eat the nutrients. Litter falls and all, they need the nutrients. And then they grow, when the tide, they go back. So they help the productivity of the sea. And then this litter will form, all the organic matter will come into the system. See, this is also the fruits and other things the animals will eat. And also that they make the roof out of this thing also. So many benefit. We have storing blue carbon, reducing climate change. Whatever you ask, the coastal is producing for us in the region. So this is the tidal flats. I think you might have seen. Maybe if you go to Hooghly and all, you will find that when there's a low tide, people run and then pick up all these prawns. You might have seen that one. Deposit muds in that one, sand, and Coral reefs. This is another important one, which is an indicator of the sea level rise, and it is also highly productive. See, these coral reefs, this is the dead coral reefs, then live coral reefs. You can take from the surface if you see that one. We are having in India coral reefs area in the Gulf of Mannar. Some patches here. Lakshadweep, we have a lot of coral reefs. Andaman, we have a lot of coral reefs in the region. Here, some patches. These are all some patches you will get. Especially here, we get a lot of coral reefs in the regions. See, these coral reefs make up fraction of the ocean, less than 1%, but they provide a home around 28% of the world marine life. That is the important of that one. And also, it is indicator of climate change, because there is a symbiotic relationship between the zooplankton and their corals. And then when there is a temperature of the seawater is rising, the zooplankton will die and bleaches, and then coral will become dead coral like this. And then once they are living coral, they are acting as shelter. They trap the nutrients. The siblings will come and heat. That's why a lot of productivity is there. Over the 4,000 different species fish rely on the coral reefs. So that much important is the coral reefs in the. So lot of work has been done in this, why the mangroves are important, why the blue carbon is stored in these regions. You can see our publications are also in our Scopus and all. You can see that one. And this you see that how much carbon burial rate. Mangroves, seagrass and tidal marsh is having the largest burial rate. That's why we need them in that one. You see the living biomass and soil organic matter. So much soil organic matter is there for the productivity to increase in these regions. Oceanic estuarine mangroves, that they have only 2% of the marine, but account for 10 to 15% of the total organic carbon burial. So 1% or 2% is still we are destroying them. We have to conserve them because they are doing a lot of job. 2% of this we gain 10 to 15%. 1% of the coral reef 40%. So there's a relationship, even though they are less in the population, but they are helping the nature. Similarly, we have the upwelling and downwelling in the ocean. Upwelling occurs when the deeper nutrient-rich water rises to the surface, replacing the warmer nutrient-depleted water. It is most prevalent along the west coast of India during the southwest monsoon. Downwelling is opposite. It occurs along the west coast of during the northeast monsoon, December. And stratification takes place. That's why the nutrients will be, productivity will be less. So upwelling zones are highly productive fish grounds, supporting rich fisheries, sardines, mackerel and other things. Downwelling also supports, because it supports surface productivity less, but deeper water it replaces the nutrient. That's why deeper water will be productive during the downwelling period. So this is how we take the ice cores in the coastal areas, that is Vladivostok course, and then you can find that the arrows summer and summer layers are all indicated in the arrows in the region. Summer, winter, we can predict how this climate change happened in the past 500 years, 300 years, like that we can able to found from the ice cores. These are the problems: pollutions, overfishing, habitat destruction, climate change, ocean acidification, invasive species, all that. So this is how the oceans we use in different, and this is the Bharatidasan University. They are engaged in the coastal area, involving the students to remove the plastics in the regions. So like if you go to Rameswaram, near to that also you'll find a lot of place, fresh water comes there, they store it, and then because of the soils which when you go to the ocean, you dig out a hole just half a kilometer from the beach, you will find the fresh water because it is stored by the dunes. Rainwater is stored and then it comes up floating on the seawater. That's why you get the fresh water in the beach areas. That is used for making small vegetable for the fishermen's, like they moved pumpkin and all, they make it in their land using this floating fresh water. And this is how we are using or abusing the ocean. Anthropogenic activities. See, there is no land now. Some islands are developed in so much for tourism. There is no land in this, and it will destroy these coral reefs and seagrasses in these regions. So how the land-based activities are affecting? See, agriculture, forestry, sewage, how they are affecting biodiversity, fisheries, oil and gas. So these are all the records available with us, and that's how some coastal regulations are developed. What are the driving factors for the coastal resource and critical infrastructure? That is, coastal change happens due to this population, industrialization, climate change, all these affecting the coastal. So we are having the exclusive economic zone. India boasts a vast, and then we're having the exclusive economic zone of 2.2 million square meters and continental shelf area. This marine protection areas are also developed. International cooperation, multiple agreement. That is the United Nations having a law of convention of sea, and the convention of biological diversity is also there in the. So we have international laws and national laws. And then these drivers, what are the impacts? We can use the DSPR approach to understand how the impact is in each of the coastal area in the region. How to manage the coastal area? That is, in order to manage that one, we need the benefit of the sustainable coastal tourism, contributes to government revenues, foreign exchange, employment. So much benefit is there in the, if you have the coastal sustainability. So we call, that is Tirukural also, we have mentioned that one. The water virtues changes with soil through which they flow. As a man companionship, so will the wisdom shows. So the water is having a uniform quality. Wherever it falls, it changes according to the soil and rock. Similarly, man, whomever is having a companionship, his wisdom changes. And whatever runs in the ocean will not run in the sea. So whatever runs in the sea, it will not run in the ocean. So our deeds and actions will depend on the place and situation. That is what Tirukural were told in the earlier periods. So there is also in the Maldives, because they are having below the sea level. So they are regenerating the coastal area, Singapore and all. They use these techniques to regenerate the sand so that the land will be increasing, rising, and then the sea level rise will not impact them. So these are the projects done by the different universities, the United Nations, in the Maldives, Singapore, and other Netherlands. That's another good example for Netherlands, which it's below the mean sea level, but this still sustain in that term. Climate change poses all these problems that is that is mainly rising temperature, change in ocean nutrients, acidity, salinity, according that is the SGD goal 14, life below water. Similarly, SGD 2, zero hunger, SGD 9, SGD 8, SGD 3, SGD 11. All those depend upon this water and this thing. Similarly, that is water in the cryosphere and ocean is also important for this following SDGs, which is United Nations has undermined. India is committed to implement all the SDGs in this region by reducing the carbon and also the controlling the rising temperature in this region. So mangroves, nature-based solution for climate change. That is why we started the work, but still now it is we are not doing much work on that one, but we started with this work. Depend upon the students' availability and who willing to go to the coastal area, we do this research. But this is something that is very important for to control the climate change. So we are having the Indians Gulf of Mannar River bioreserves in Tamil Nadu, Sundarban bioreserve West Bengal, Great Nicobar bioreserves. So we are also conserving this thing. Government is taking action of that to conserve these bioresources. So these marine bioresources are crucial sanctuaries of marine diversity, protecting vital habitats, threatening species. They are also producing sustainable practices of fishing and tourism. So social and economical benefits will be there in that one. And then these are all that international laws are there, continental shelf and territorial water internal areas, exclusive economic zones, high sea areas according to laws. So to make that free freedom for navigation, innocent passages, exclusive economic zone, settlement of disputes. So that is the United Nations Convention of Law and Sea was adopted in 2000 to reduce. India is also a member of that one. So any dispute is there, we will go to them, and then the Ministry of Earth Science is an important component place there. So India is also having the coastal regulation zone, integral zone, and then we classify them: the coastal regulation 1, coastal regulation 2, coastal regulation 3, coastal regulation 4 by Ministry of Environment and Forest. Ecological sensitive areas like mangroves, all those things comes in the CRZ1, coastal regulations in 1. CRZ development with municipal limits. So regulated developments will be permitted here. CR is the rural area, some development will be permitted here. CR4 exclusive for islands. We developed this. CR is at 4 in these regions. So this is how the management we have to do that. That is control the pollution, habitat restoration, marine protection, sustainable fishing. Because so that's why there is always, you find in the news, they will, when there is a breeding activity of the fish is there, then they will stop the fishing. So 1 month they will not allow when the breeding is taking place, so that the next generation will grow in that region. So we should have the controlled sustainable fishing, habitat restoration, like coral reef restoration. Wherever there is a destroyed coral reefs, we are artificially creating the coral reefs in the regions. So another one concept is coming is that the blue-black certifications. That is ecologically, and that is ecotourism. For that, the international organization, Foundation of Environmental Education, Belgium, they have a certification they give inspecting that in that one. So in India, we have these are the beaches which are now certified by them, from the Orissa to Lakshadweep to even almost all the states. We are having this one in the beaches in India. Thank you very much for your patience. If you want to ask anything, we can.
Thank you so much, sir.
Thank you.
Thank you so much, sir.
If you have any question,
Thank
you
you
can
so
ask.
much, sir. It was a very nice presentation. We have to know lots of things. Thank you, sir.
Thank you, sir.
Thank you.
Thank
Thank
you
you,
very
sir.
much, sir.
Thank you. Very
Jyoti.
nice information, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you. I hope it is useful to you somehow or other.
Sir, thank you. Very nice explanation, sir. Thank you.
Thank you, sir. Thank you.
Anyone have any question?
Okay.
Thank you very much.
Yeah, any question?
Thank you so much, sir. Now I would like to invite Dr. Ahmed Masood Khan.
What, sir? Anything?
Shares and marine system. Your talk on these two topics really highlighting the critical role of glaciers, reservoirs of minerals and nutrients, but also the detriment of black carbon and pollution on their. Further, your insightful ecosystem, their connected ecosystems such as coral reefs, mangroves, and their role in burning carbon and reducing the effects of touching under of our collective responsibility to preservation of our planet. Concretion is invaluable ecosystem for future generations. Once again, thank you for your invaluable contribution to our understanding of these pressing environmental issues. On behalf of all, I extend gratitude to Professor AL Ramanathan. Thank you once again, sir, for accepting our invitation. It's valuable for
Thank you very much.
Thank you so much, sir.
Thank you very much for your patience and listening.
Thank you so much, sir.
Thank you.
Thanks, sir.
Audience, with this, we end today's session. No, we will meet again tomorrow with another talk. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you very much, sir. Thank you very much.
Thank you very much, sir.
Thank you, sir.
Thank you so much.
Kalim
Thank you so
sir,
much.
Kalim sir. Hello. Hello, Kalim sir.
Kalin sir has left.
I think tomorrow will be valedictory session, huh? Sir, others present here.
Yes, hoga.
27 ना sir, validity pension. Next day.
हेलो आप लोग असाइनमेंट अपलोड कर पाए ना सब लोग?
नहीं,
Yes,
मेरा
yes.
हुआ।
Yes, yes, sir. Yes.
सब लोग ने कर दिया ना?
जी
हाँ
सर।
सर, मैंने अपलोड कर दिया।
Yes, sir. We have uploaded.
No, मैं नहीं किया assignment
अभी अभी मुझे भी आज करना है 26 लास्ट डेट है ना आज करूंगी अभी
आज लास्ट डेट है।
अच्छा, थोड़ा इंक्वायरी था कि कोई एग्जाम होगा क्या?
कुछ
नहीं
पता
होता है,
नहीं।
No
STC में
exam.
नहीं होता है।
Oh, no.
कुछ सर कुछ पता नहीं है।
Only assignment by video lecture.
ओनली असाइनमेंट नहीं
Only
होता है, एग्जाम नहीं होता है, इसमें एग्जाम नहीं होता है।
अच्छा है तो ठीक है, एग्जाम नहीं तो
No exam in short
इस
courses.
वीडियो
Very
वीडियो
nice.
ड्राइव पे रख के आप लोगों ने लिंक कॉपी किया है
नहीं वीडियो
मैडम,
ही किया
नहीं मैडम,
अपलोड करना है क्या लिंक देना है मैडम?
वीडियो अपलोड कर दिया
You
है।
can share your
वीडियो
link
हमने
also.
तो अपलोड किया
Infected
वीडियो
yesterday.
अपलोड किया हमने
मैडम अपलोड करना है कि लिंक
दोनों
देना
कर
है?
सकते हैं, कोई भी हो जाएगा, दोनों तरीके से कर सकते हैं।
ओके ओके सर।
ठीक है हाँ यस यस ओके
थैंक यू ऑल ऑफ यू।
We will meet tomorrow. Have a good day. Thank you.